talking about the physics of air hockey today, and before we talk about that, we have to talk about the law of conservation of energy. It states that energy cannot be created nor destroyed, and it applies to collisions because in collisions it may look as if energy is created, but in fact it is not. Instead, it is transferred between two systems. This also applies to momentum.
Two different types of collisions are elastic collisions and inelastic collisions. In elastic collisions, two objects hit and object 1 stops while object 2 keeps going, and translational kinetic energy is conserved. In inelastic collisions, when two objects hit, object 2 keeps going and object 1 keeps going also, but object 1 is going slower than object 2. And transitional kinetic energy is not conserved, but momentum is.
During perfectly inelastic collisions, the objects tend to stick together after the collision. So when object 1 is traveling to object 2 and they collide, they move at the same rate of speed. This is the maximum loss of translational kinetic energy, and they have the same velocity after the collision because they're traveling in the same direction at the same rate of speed. And during explosions, stored energy is released as translational kinetic energy, but the objects move in opposite directions.
I will be modeling an elastic collision on this air hockey table, which all translational kinetic energy is conserved so that when one puck strikes the other, it'll stop and the second puck will continue, just like this. Now we'll be moving on to the pool table, where we'll be doing an inelastic collision, which all translational energy is not conserved, so when the cue ball strikes the 8 ball, the cue ball will continue to go forward with the 8 ball.